So first we are going to see about this quantitative structure activity relationship. Okay. So basic things about this quantitative activity structure relationship is that activity structure relationship. This is what initially it is called as ASR. That is activity and structure. So if similar compounds having similar structure, then they may have similar activity. So that is the concept of activity structure relationship arised. And then how to quantify it, how to quantify the relationship. So in that way, the concept of quantitative activity structure relationship QSAR concept is arised. So on the basis of this QSAR concept, we can able to screen the chemical compounds. If you know some compounds having some activity, then we can use those compounds to create a common parameters. By using that common parameters, we can screen the whole databases. From the databases, we can retrieve few molecules on the basis of this quantitative activity structure relationship. That is known as the QSAR model. So based upon the concept of activity and structure, they have similar roles. On the basis of that nature, we can screen the unknown compounds to identify the suitable compounds from the unknown compound list. So that is known as this quantitative activity structure relationship. So in today's class, we are going to explain this concept with the help of Datawarrior tool. So in the previous classes, that is in the previous fourth session, we had downloaded molecules in SDF format. I hope everybody remember that. So now we have to use that SDF file. I hope you remember. The compounds are downloaded in the SDF format. So we can open that SDF file in this Datawarrior software. So it is a Datawarrior software is a freely accessible software for analyzing chemical compounds, for screening chemical compounds, for calculating the molecular descriptors, and for docking purpose also you can use this tool. So it's a multi-purpose tool. So in today's class we are going to see about this tool for the QSAR screening purpose. We are going to see this. So we will open Datawarrior. Okay, now we will open a file. Open this selected or this SDF database file. It is the file which was containing more than 1000 odd molecules in a SDF format. You can see now. See, this file will contain around 1031 molecules. So are you able to see my screen now?
Yeah.
So is it visible?
Yeah, we can see.
You can see this. There are about 1031 molecules are present in this particular SDF file, which was already prepared as per the previous session class. So this is the structure of the molecules, and these are the other properties of the molecules which are downloaded from the PubChem databases. Okay. So out of this 1031 molecules, we are going to now screen on the basis of QSAR concept, quantitative structure activity relationship concept. Okay. So now for that, what we have to do is first we have to go for this data, and then there is a chemistry. In the chemistry from chemical structure, in this chemical structure calculated properties. Once again chemistry, and then chemical properties. In this chemical properties, calculated properties. In this we will go for this average molecular weight option to be enabled in drug likeliness, log P values to be enabled, log S values to be enabled, hydrogen acceptor, hydrogen donor, then total polar surface area TPSA calculation, and drug likeliness calculation to be enabled. In next category, in toxicity prediction, mutagenic, tumorogenic, reproductive effective, irritant nature, and Panis pattern. And then these are the few parameters to be enabled. And then in atoms count, stereospecific centers and rotatable bonds can be enabled. And we can also design depending upon the, if you know the whole concept of QSAR, you can enable different parameters, and depending upon the condition also we can select different parameters. For the explanation purpose, for the today's class I have selected only few important parameters. Okay, so but one can select all these parameters and they can run all these QSAR analysis. Okay, so now I have selected only few parameters which are very essential for drug discovery, drug designing purposes. Okay, so for that only I have selected 1, 2, 3, 4, 5, 6, 7 and see 8, 9, 10, 11, 12 and then 13, 14 parameters. Now I will click this OK button. So now it is going to calculate all these properties. So calculated properties are added to this already available properties. See, already these are the properties added to the chemical structures retrieved from the PubChem databases. Now we are calculating certain parameters, that is molecular descriptors, and they are also added at the end of this table. Once the values are calculated, we can screen the chemicals based on those parameters. What are the parameters to be used for quantitative structure activity relationship? And these are the databases which are used for drug designing purpose. You can see that few of them are listed here. If we go to this drug designing, you can see. See here. So these are the parameters to be noticed for drug discovery purpose. That is, first one is molecular weight. So the molecular weight should be always less than 500, and then the log P value should be under 5, and log S value should always be between -1 to -5, and hydrogen bond acceptor value should be less than 10, and then hydrogen bond donor value should be 5, and then TPSA value should be under 140, and rotatable bond should be less than 10, and stereo centers will be very nice if it has only one center, and low mutagenic property, tumorogenic property, irritant property, and reproductive effective property, and then Payne's pattern should be present, and drug likeness values is always better if you have 0.5 to 0.6. So we have to fix all these values in this Datawarrior. Okay, so now I'm going to fix. So now all these newly calculated values are listed here. You can see now. Previously it is not added, up to this it is present. Now you can see molecular weight, log P, log S, hydrogen acceptor, donor, TPSA, drug likeliness, mutagenic, tumorogenic, these values are added. So depending upon these values, we are going to change the values here. See, we can reduce the molecular weight. Sorry, this is molecular name. If we go down, we'll see the parameter like molecular weight. Here it is a molecular weight. So now we will reduce the size of the molecular weight less than 500. So if I reduce this molecular weight less than 500, you can see now the number of compounds is reduced. So see, when I place it below 500, you can see the number of compound is reduced to 80. From 1031, it is now reduced to 80. So this is how, by changing these parameters, we can screen the databases. Now you can see the log P value should always be less than 5. So you should reduce this up to less than 5, and log S value is also should be present. So I told you, you can see this -1 to -5 it should be present. So you should reduce -5 if it is present, -1 to -5 it should be present. minus 1 to minus 5. So minus 1 here, and here it should reduce to minus 5. So this is how we can change it. So we can see now the number of molecules will be reduced to 53, and again hydrogen acceptor should be less than 10. So this value should be reduced to less than 10. Again hydrogen bond donor should be less than 5. See now again the molecule is reduced to 44, and again total polar surface area to be less than 120 or 140. So we reduce this value to less than 140 or 120. You can see this 140 is enough. So if it is less than 140, and then drug likeliness should be like 0.5 to 0.6. Mm-hmm. 5 to so now when you reduce this 0.5 to 0.6, you will get the number of compound is very much reduced. See only 4 molecules are listed out here. Then you go down and release this mutagenic high compounds should be released, and reproductive effective compound should be released, irritant that should be released, and then if you remove all these things, and rotatable bond should be less than 10 or 12 it should be. You can see now the rotatable bond should be less than 10, so we are keeping it less than 10. So once you fix all those things, now you can see only 2 compounds are screened. Okay, so this is known as QSAR screening. So on the basis of a quantitative structure activity relationship, we have already developed this particular group of compounds based on the already available drugs. Okay, so if you collected more than 1000 molecules which are having similar structure to that of a drug molecule, then on the basis of quantitative structure activity relationship, we screen the 1000 molecules and find out 2 suitable chemical molecules which are similar to the collected drugs. Okay, so that is how we screened this particular 2 compounds from the databases. Okay, so by seeing this, you can see the difference between the molecules. Okay, so there are 2 molecules are selected on the basis of this QSAR by using this Datawarrior tool. Once you screened these 2 compounds, you can select these compounds by left click mouse and press the shift and again left click the mouse. So the 2 molecules are selected. Now go for file, export option, and select SDF file. So now you are going to save the selected SDF file. So automatically we will save this. So that this is how we screened the 1000 molecules into 2 molecules. Okay, now we will open the file once again, the selected file, whether it is having only 1-2 compounds or not, we will check. So now Datawarrior, again we will open file, open. So you can see this is the selected SDF file, is the newly created file. I will open the file. Now you can see this only it contains 2 compounds, total is 2. So it is only selected molecules are present in this particular QSAR screen. So this is how you can screen any number of compounds based upon few parameters. Okay, especially those parameters are used for drug designing purposes. Clear?